For this video, I want to go over some steps on how to go through a service call using our current simulator product that we are using. So for this service call, we have a customer who is complaining of their burner is igniting and then immediately shutting off. So at the beginning of this service call, we need to start thinking about some of the possible reasons that would cause this issue. We have to think about a service call in a very systematic way. The first thing that we need to obviously know how to do is we need to know the sequence of operation, and we need to know how a furnace works. So in order to do that, we need to study the electrical diagram of that particular piece of equipment. So what we have here is a wiring diagram for a very basic high efficiency gas-fired furnace. We have some pretty basic safeties in this. We have a gas valve, we have a flame sensor, we have an ignition module, we have a thermostat, and obviously we have our blower motor, vent motor, and our igniter. So the customer is complaining that the burners fire but then immediately shut right off. So that should be a very big clue to what is wrong with this particular piece of equipment. So the first thing that we always do on any service call is, okay, the customer is complaining of this or complaining of that. We as the mechanic should be the first ones to turn everything on and physically see for ourselves what is going on. Okay, so we know that our thermostat is calling for heat because we can verify that. We can go across our R and our W. We're getting 0 volts. We can double check to make sure that we are getting 24 volts by checking our transformer, and we are indeed getting 24 volts. We know that the vent blower is on. So with the vent blower being on, we know that our coil for our heat relay and our contacts for our vent motor are closed. We are reading 0. So we know that all of that is good. But we are having an issue of this particular piece of equipment not staying lit. So what could that possibly be? Well, we need to double check and verify, obviously, that all of our safeties are indeed working the way they are. So the first one we're going to do is let's check our vent pressure switch. Okay, the vent pressure switch, well, we're saying we're getting 24 volts there. That's simply because we are now reading our ignition module, our TH and our TR. The ignition module is a load in this particular application. So what we're going to do is I want to go right across that switch. So I'm going to go right there. I'm reading 0. So that's telling me that that switch is closed. What about my rollout switch? My rollout switch is also closed. I'm reading 0. My high limit switch, I'm closed. I'm reading 0. What about TH and TR? Because that's our next line, TH and TR. Okay, I'm getting power to my module. So I know that I'm getting my power to my ignition module. It should begin to work. So let's watch. Let's see what's going on with this piece of equipment. Let's see what it does. Let's give it a couple of seconds. Okay, hot surface igniter is glowing red, which is good. gas valve is opening and firing, but we're immediately shutting off. So the customer is indeed telling us the truth, that this is exactly what is going on. So we know that the ignition module works, we know that our hot surface igniter works, we know that the gas valve is not working. Because we're firing, we're good. But what is not keeping our furnace lit? There's only really one piece in this entire component that may not be working properly. Okay, on a high efficiency fired furnace with a hot surface igniter, we will usually run into our flame sensor. Remember, the flame sensor on a gas-fired furnace is the device that will send the signal to the ignition module, telling the module that it did indeed light. If that flame sensor is not sensing properly, it's not going to get the call. So why don't we double check, and let's look at our flame sensor. Can we verify our flame sensor? Oh, well, look at that. Our flame sensor isn't even going to sit in the flame. What we can do to verify that our flame sensor is indeed not working properly, we can actually take a microamp reading of the flame sensor itself with the furnace actually running. So why don't we do that? Usually on a good flame sensor, we're looking at somewhere between 1 to 1.5 microamps for a good flame signal sent back to the module. We can also look at the specifications for our igniter and what we're dealing with. So we have a microprocessor type ignition module with a 30-second pre-purge, 17-second warm-up, 7-second trial for ignition, and a 60-second wait and retry cycle. Okay, the retries for this guy is 2. Recycles, if the flame is lost, it's going to try it 4 times, and then after the maximum retries or cycles, it will lock out. Okay, so the dummy lights, obviously if the light is on, that's normal startup. Flashing 1, sorry, that's normal startup. Steady on, it has an internal fault in the module, or flashing, the lockout or external fault of some sort. Okay, so our flame sensor, which is really what we're looking for here, the maximum current that we're looking for is 1 microamp. Okay, maximum current for non-detection, 0.2 microamps. So why don't we see what we're dealing with for our flame sensor. Let's see. Let's go there. Alright, so right now we're reading 0 microamps. So why don't we turn this guy back on, and let's see what we get for a microamp reading. That way we can actually verify whether or not that flame sensor is indeed not sitting properly inside the flame. So let's give it a little bit of a time here. Remember, we got a little bit of a warm-up cycle. Again, it's 30-second pre-purge and then a 17-second warm-up. Okay, so we got a little bit of time. So, okay, here we go. So let's go over to our diagram and let's see what we get for a microamp reading. Nothing. Look at that. Not even getting a signal. So we have confirmed that the flame sensor itself is not doing its job. So we need to repair that. So we go over to our little symptoms chart here, and let's see what we can figure out. We know that the burners are lit. Okay, the burners ignite and then shut off after trial for ignition. Burners on, but igniter won't shut off after trial for ignition. So let's see, let's go with that one here. Burners ignite, then shut off after for trial for ignition, because that kind of sounds like what's going on. Oh, here we go. We got a flame sensor not properly positioned in the flame. So let's repair that. Okay. We can now go back and verify that we did put the flame sensor back where it belongs, and it is. So now let's go and try it again. Let's see what happens. And again, let's check that microamp signal. Let's make sure that we're getting what we're looking for. And we can also take our gas reading. In fact, actually, why don't we do that? Let's put on a gas manometer and let's see what we're getting for gas pressure, because we want to make sure that this guy is working absolutely 100% the way we want it to. So let's put on a gas manometer. Let's see what we're getting for gas pressure to our manifold. Okay, remember, this is natural gas, so natural gas for our manifold pressure, we're looking for 3.5 inches of water column. We can visualize our filter. Let's make sure that our filter is nice and clean. Okay, we can look at our blower. I believe, maybe, possibly, no. Let's look at that. Heat exchanger is nice and clean. Got to turn our gas valve back on. Three and a half inches of water column. We're staying lit. We're getting 1.5 microamps to our flame sensor, and we're staying lit. We have successfully completed this service call. We can honestly say if everything is actually working properly. And that's how you do it. The system has been repaired. And that's how you troubleshoot and verify whether or not a flame sensor is actually working properly.